Okay, I chose to look a little deeper into different base systems other than base 10. I had tried to teach it in the past with a group that needed some extra challenges, and what I realized is that I was more so teaching it for mastery and memorization than I was for its true purpose of exploration. So I looked into some sites online and I looked into the files that I have and I found some ideas for introducing base systems other than base 10 in an exploratory way. Before I would do this, I would make sure that my students had a solid base and knowledge about our base 10 system as a positional system where each position is a power of 10. I would also make sure that my students understood that position can be a power of 10 as each place, as we move larger, is 10 times the one that's to the exact right of it, the second smallest place. So this is times 10 times the size. So 1 to 10, 10 times the size. And as we move this way, my students would understand that this is now 100 times the size of 1, 10 times 10, or 10 times the size of the tens place. And 10 times 10 makes sense for why this place would be called then 10 to the second power. Moving forward, this would be 10 times 10 times 10, or 1,000 times as large as the ones place, and 10 times as large as the tens place. And this makes sense that 10 times 10 times 10 would be referred to as 10 to the third power. Finally, the last one that we would focus on in relation to other bases, 10 to the fourth, 10 times 10 times 10 times 10. My students would understand that this place is 1,000 times as large, or sorry, 10,000 times as large as the ones place, and 10 times as large as the thousands place, which makes sense why it's 10 thousandths. This would have to be a mastered skill in order to be able to get the most from what they could in experimenting with other bases. In addition to that, this chart would then look very familiar to students who have already mastered base 10. The way in which I would introduce the idea of packaging in terms of gaining a number that is the most efficiently packaged, I would play a couple different games with students. First, I would introduce this game in base 10 as a review activity, nothing more. Before we would start, we would discuss how when we are placing numbers positionally into the system, it is done so kind of with the analogy that we are filling boxes that can hold a specific amount, and that when we fill these boxes, we fill a box to its maximum potential before we go to the next item or group. So we would fill a box that can hold 100 to the top before we would fill boxes that fit 10 and so forth. We want the least number of boxes or groups to hold these items. So what we would do is we would pair students, have students do this independently. They would need dice, and what they need to do with this dice is roll. Okay, so this would be a 6, so the students would have to take out 1, 2, 3, 4, 5, 6 items. Okay, so at that point, this would be the least amount of items for this grouping. Okay, so that student would roll again and get 4. 1, 2, 3, 4, and what they have now is 10 ones. So there is a more efficient way to represent this, and that would be with 110. Okay, so the students would swap that out. Okay, so they would then take these out. It's the same amount of items, but more efficiently grouped. They would continue to roll, rolling 5 more, 5 ones. Okay, roll again, 3 ones. At this point, it's still the most efficiently packaged. So they should have 1, 2, 3, 4, 5, 8 ones. Roll again, 3 ones, 1, 2, 3. Now at this point, we are able to do a trade of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1 more hanging out after we swap out these 10. Okay, so the point is that the kids are just practicing efficient packaging in terms of the base 10 system, using a dice and using base 10 blocks. They could do this on the computer. There are some great sites with virtual manipulatives, but I feel that it might be best to have them experiment with the actual blocks themselves. Okay, so I'm going to X out of this for a second. After students had the time to play with this, I would call them back together and ask them to make a prediction about what they think would happen if we had to take the same number of items, okay, and put them into smaller boxes. So with the number of boxes you need, increase or decrease if we move to smaller boxes. And we would have a discussion with that, and that would lend itself into a transition into base 5, where the boxes can fit less. To start, I would show them this chart, and we would discuss the ways that it looks similar or different to this chart. First of all, there is the same kind of looking items, so meaning we have a 1, we have a rod, we have a flat, we have a long flat, it's sometimes called, or a big cube. So we have the same looking ones, but as the students look a little bit closer, they might pick up on the fact that there are less units within these places than the base 10. So that would then lead us to a discussion of how to name these places. So we know that base 10, each exponent has a base of 10, and then in base 5, we all have a base of 5. And when we look at the names of these places, it behaves in a similar way. We have 5 to the 0th, meaning just 1, 5 to the 1st, which is 5, and that makes sense because there's 1, 2, 3, 4, 5 units here. 5 squared, which is 25, 5 to the 3rd, 125, and we're going to stick in this region for now. We will probably come back to this later. We would then talk about how if this system functions the same way as base 10, it will likely have the same type of idea that the 5's place, this place right here, is 5 times the size as this place right here. Okay. We would also then talk about how this place right here with the flat, this is 25 times, or 5 times 5 times the size of the 1's place, and 5 times the size of this place right here. And moving forward, this would be another 5 times the size as the one before it. So this would be a conversation that we had when we were naming our places using what we know about base 10. Now we're working with a system where all of our positions have our sum power, the value our sum power of 5, which makes sense because the name of this system is called base 5. Again, it's a positional system, meaning that the value of this is 125. The value of this place is 25. The value of this place is 5, and the value of this place is 1. Okay, so what we would do is that we would have a brief conversation about this new base system. We're not doing all our teaching here. We're giving them some type of introduction to work with as we move forward. What we would do then is actually play that same game that we did with base 10, but now with base, oops, messed that up, with base 5. 5 to the 1st, 5 to the 2nd, 5 to the 3rd. We're not going to get to this in that game. So what students would do would be to, let's actually move to this one so I can grab those cubes. They would take that same dice and roll just like they did before. So they would roll first and get 2 units. Okay, at this point, this is the most efficient way to group, to have these items listed in this chart, because our next base, or our next place up, is 5. So we have to keep in our minds that when we get to 5, we can make a trade out. So let's roll again. We have 4. 1, 2, 3, and 4. So So now we are able to repackage to be most efficient, meaning we have 1, 2, 3, 4, 5. So we're able to trade those out for this. 2, 3. Okay. So at this point we have 1, 5, and 1, 1. We can continue to roll, gaining another 5, and some students might take these out and actually regroup from right here, and other students might pick up on the fact that this is a 5, and this would be the least way of representing it. So now we have 2 5s and 1 1. Moving forward, we have 1 unit, still in the most efficient packaging. Roll again. 4 units. 1, 2, 3, and then 4, and we are able to make a trade out. Okay, we'll bring this in and we'll take 1, 2, 3, 4, 5 units out and continue to roll. Okay, as we move at 4 on, 1, 2, oops, forgot it behind, 3, 4, 5, we can make the trade of 1, 2, 3, 4, 5 for one of these longs. Okay. So now we have 4 5s. Some students might call it 4 5s. Others might pick up on the fact that this is actually the same thing as 4 5s would be 20. And we would encourage them to think in that way as well. I'll do enough to get into the next space. So we have 6. So 1, 2, 3, 4, 5, 6. We definitely need to group here. We can bring in this 5 right here, take out 1, 2, 3, 4, 5. And now what you might notice is that we have 1, 2, 3, 4, 5 longs. And that is the same thing as this flat right here. We have 1, 2, 3, 4, 5. So this would be the most efficient way to represent that. So at this point we have 1 of 5 by 5, 125, and then 1, 1. And kids would continue to do this. Teacher would be circling around to see that they are trading and making the trades and making those packaging decisions the most efficiently that they can. With ample time to practice that, depending on the day, maybe the same day the next day, the teacher would move forward to base 3 and do the same thing. Have that discussion first about how our bases remain the same. Base would be the dreaded, I hate this way to say it, but the big number in an exponent. And just like base 10, this is to the 0th, to the 1st, 2nd, 3rd, and 4th. And so what we would do then was talk about the value of each position. And it's as easy as not even referring to the exponent as much as looking at the picture. Because these are so, there's so few in each place. This is 1, this is 1, 2, 1, 2, 3. This is 1, 2, 3 by 3, which is 9. 3 by 3 by 3, which is 27. And 27 times 3, let's just check that really quick. 26 plus 2 is 8. Okay. So we would tell them that, essentially, this place right here is the 81's place. This is the 27's place, 9's, 3's, and 1's place. And then we would also have that same discussion about how, because base 10 functions in this way, likely this system functions the same way, where this one is 3 times the size, moving forward 3 times the size, 3 times the size, 3 times the size. So I'm running out of time on my recorder, so I'm going to have to speed up a bit. Anyways, the students would have to play this game with the base 3 and talk about afterward the differences they pick up on with their peers and with their teacher guiding that discussion. The last activity I have that is intended to introduce the positional values or place values for base 4 would be an activity called the Base River Ferry Company. Actually, I'm going to end here and then do another presentation about this in just a minute. So hang tight. This is, I think, really important, so I do want to include it.